In previous videos this week, we've introduced iteration and dictionaries. So in this video, we're going to use visualization to help us understand both of those, and also to introduce one more way of doing iteration. In this example, we're going to square each element in a list, returning a list of those values. Okay, so I've run it in Viz mode, and now I'm ready to step through it to see how this happens. Okay, we call our function, and the first thing that we're going to do is initialize a list to be empty that's going to hold all of the resulting squares. Right now we haven't looked at any of the original numbers, so there's none of the squares in this list. Now we're going to start our loop. Okay, we ask, are there any elements in this loop? And we say yes. In fact, the first one is the value 4. So all right, what do we need to do with that? We're going to square it and add it to the end of our list. So we've added that to the result of our list here, the square of 4. We go back to the beginning of the for loop, ask, is there another element in our list of numbers here? We say, yes, indeed, there's 5 in the list. Okay, so we're going to square that and add that to our list. And then ask if there's another element. There is. We square and add it to the list. And once again, after having asked, is there another element? We say, well, no, there isn't. So we're going to return our list that we've built up. And we return it, and it gets printed. This previous example illustrated a common pattern. For each element in a given list, we're going to build up a new list where there's some element-wise computation that each element in the result depends upon an element of the original list. Okay. Well, this pattern is very common, and there's another way to do this. Okay. We're going to introduce a list comprehension that syntactically is it's saying I want to do this computation, squaring in, for each element of this list, numbers. Okay. Notice that the syntax is taken from pieces of the first version. Okay, we're squaring each in, and we have for in and numbers. Okay, the other parts are just sort of part of the common pattern here. Okay, and we surround the entire list comprehension with the square brackets. Let's run this and verify it does the same thing. Okay, we define our functions, we call, and we say, well, numbers is our original list. I'm going to create some temporary list here that, well, I've squared the first element of my input list and put the result into my temporary list. I square the next element and put the result into my result, and square that and put it into the result list. Okay. And finally, I return that list and print it out. So once again, what we're doing here is doing an element-wise computation, in this case squaring each element and building a new list out of those results. When you're doing an element-wise computation and building a result of those lists, that is commonly called mapping that computation, that squaring here. And we can do that with a list comprehension. In this example, we'll illustrate another common pattern in a for loop here. So in this one, we are looping over a range of pairs that represent the centers of where our balls are. And we're going to pick out and select only those that meet some condition, that are in some particular range. Okay? And build up a resulting list of just those that we want. Okay, so, well, we define our functions and call here. And so the idea is we initialize our, we pass in our function and initialize our resulting list to be empty. And each time we're going to test if this, well, right now this 0th element of our list, we're going to look at it and call, see if it's one that we actually want. In this case, it wasn't. So I'm not putting it into my empty list. Instead, I'm starting over the next iteration of my for loop. So I'm going to look at the next ball, ball number 1, and I'm going to call my test function is in range on it. This time it returns true. So I'm going to put that ball into my result. Okay. Notice the aliasing here, actually. It's actually putting a reference to that ball that's shared with the reference here. Okay. They're actually the same pair that is in both of these lists. Okay. We continue on looking at the next ball here, the next location. We find that it is not in our range, so it does not end up in our result list. We go to the next element of our input list and decide that we do want to keep it. And so we're going to add it to our list. Okay, notice that this is getting more complicated here, that the first element of my list is this ball. The second element of my list is this ball, okay, or 0th and 1th elements. And these references are shared with, well, in fact, they are the same references as here. Okay, so this picture gets a little bit complicated here because it's really the same underlying things that are in both the original list and the resulting list. Okay, but we've exhausted our input list. There's no more balls, so we're going to return our result list, which is this right there. And that's what gets printed. The previous example illustrated a common pattern of building up a new list based upon an old one that simply keeps the elements that we choose to want. Okay, so this is often known as filtering, and it's also a feature of list comprehensions. So here is another way of writing our function. So let's look at the syntax first. That once again, it's just going to take pieces of our original version. That the computation we want to do on each ball is, well, nothing. We just want to add it to the list. Well, where are we getting each ball? Well, we're getting it by looping over the list balls. But we're only keeping it if it matches this condition of being is in range. So each of these pieces is in our original function, and then once again the whole list comprehension is in the square brackets. So let's see how this actually operates here. Define our functions. We're going to call, and so we initially have balls as this list, and we're building up a new temporary list because after all we don't have a name for it here. And so initially we say, I want to look at this 0th element. And well, I'm going to pass that to is in range to test if I want it. I don't. So I'm not going to put it in my list, but instead I'm going to go to the next element here. I'm going to look at that element of my list. I'm going to call is in ball on it. Find out I actually want it in my result list. So I add that to my temporary list here. And once again, it's sharing these pointers. I look at the element number 2, decide I don't want it, skip to element 3, decide I do want it in the result. So I add that, add a reference to that as the next thing in my result list, my temporary result. In this case, what do I do with that temporary result? Well, I'm going to return it. So that's my return value, this 2-element list right here, which is each references. And then I come out here and print it. So in summary, list comprehensions allow you to both map elements, meaning do computation on each one, putting the results in a list. It also allows you to filter or select the ones that you actually want to keep. While we separated that out into 2 different examples here, you can also combine them. So for example, we could have said, only keep the squares, build up the squares of just the odd numbers and do both the selection of odd numbers and the squaring at the same time. So for our last example, I want to use this encoding and decoding code that was used in a previous video. So I've already run it, and now let's step through. And I want to focus on the iteration here, of course. Okay. So I first gave it the message babe, so that's not terribly interesting here. I want to go to encoding, where it's going to encode babe. And so it comes to a for loop. And really the main thing that's interesting here is that this for loop is over the message, which is a string. So we can have for loops on strings. And so here where the message is BABE, so we look at a character B, do some encoding. We look at the next character A, do some encoding and add it to the result list. We look at the next letter, encode it, and then finally look at that letter. We decide, there's no more letters, so I'm done, and I print out the encoding. All right. Well, so now I type in that resulting encoding so that I can decode it back. Okay. Now, a couple things I want to point out before we get there. We have two nested for loops. One is on a string. One, we're also doing this idea here that we're what's called unpacking a pair. So cipher.items is a list of pairs, and we're going to assign each part of that pair to a different variable. Okay, so how do we understand all of that? Well, we initialized dMessage. Then we're going to start our outer loop. Okay, ch gets value. Key and value each get values simultaneously. Okay. And then we do the if inside it. And then, okay, well, we keep repeating here the inner loop. As I keep stepping through, it keeps going through. And then finally, when we're done with each of the cipher items, well, we only have 5 things in our cipher, so it only takes 5 loops. And then we go to our next character in the message, which is the X. And then we're going to cycle through another 5 times here of our inner loop before we go back to our outer loop. And we'll continue this with each of the other 2 letters in our message. Okay. So you can see that stepping through with iteration here using our visualizer helps us understand the structure of these loops. In this case, the interesting thing here was really the doubly nested loop, that we go through all instances of the inner loop before we return the outer loop and go through the next instance, and then go through the inner loop a bunch of times again, and then return to the outer loop, etc.